Using the information from the ANOVA table below, find a 95% confidence interval for the difference of the population means from the jump and flash treatments. And here's the jump treatment and the flash treatment. And suppose you performed an ANOVA test on this, and that is you were testing the null hypothesis was that all of the means were the same, and the alternative hypothesis was that at least one of them was different. And you get this very low p-value, which would cause you to reject the null hypothesis in favor of the alternative, which would say at least one of the population means is different from the others. And it's probably this Jack. And then you come back and say, well, look at jump and flash. Well, those sample means are pretty close to each other, so let's find a confidence interval for the difference of the population means. And the formula for that confidence interval is the difference of means, the difference of sample means, x bar sub 1 minus x bar sub 2, and then plus or minus, so you've got your point estimate, the difference of the sample means is your point estimate, but then there's some margin of error, so plus or minus the t-value times the square root of the mean standard error of the ANOVA table times 1 over n sub 1 plus 1 over n sub 2, the sample sizes for jump and flash. All right, we're going to go through this step by step. First of all, the x bar sub 1 and sub 2, those are just the means from the jump and the flash. So I'll go ahead and write that down right here. That's 9.83 minus 10. All right, and then plus or minus. Now the t, this t is the t-value from the t-distribution that is associated with a 95% confidence interval, because that's what we have, that's what we're asked for, 95% confidence interval, and then we have n minus k degrees of freedom, because remember the t-distribution has these degrees of freedom. Well, the n in this formula, in the degrees of freedom, is the total number of observations, which in our case is 15. And I know I have highlighted 6 and 5, but we have to include the 4 because it's the total number of observations. So that is 15. K, then, is the number of treatments. And for this example, it is 3. The total number of treatments is 3. So we have our n and k. So n minus k is going to be 12. 12 degrees of freedom, right? 15 minus 3. So the associated t-value for a 95% confidence interval with 12 degrees of freedom is equal to 2.1788. Now, continuing, we have the square root of MSE, and that's this right here. I highlighted that so we could just pull that out from the table, the mean square error. So 1.9028 multiplied by 1 over n sub 1, that's 6, the sample size of the first treatment, plus 1 over 5, that's the sample size of the second treatment. That's the square root of all of that. Simplifying all of this, add these fractions first, and then multiply, and then take the square root, and then multiply that result by 2.1788, and you get a negative 0.17, that's 9.83 minus 10, plus or minus the product of all of this, and that is rounding 1.82. So your confidence interval in the end is negative 1.99 to 1.65.